Hey everyone, let's take a look at this example. It's kind of the same example that we've worked on in some previous videos, but I've done a couple of things now. One of the points that we did between A and B, when we did in previous videos, we looked at 4 meters and 6 meters, but now what I'm going to do is I'm going to choose point T here, and I'm going to put it at some arbitrary distance x away from point A. So I'm assuming that the x-axis is origin is at A and it's going to the right, just to kind of make life simple. And then I choose another point U. You recall from a previous video that was at 9 meters, but again I'm just going to make it some arbitrary distance x away from point A. And what we want to do is we want to find out what are the moments and the shear forces acting at these arbitrary points. So we saw in a previous video that the shear forces might be the same in between A and B, but it was different on one side of A than it was on one side of B than on the other side of B. And that's because of this force that's going to come into play at B. But the moment was different at 8 meters, at 4 meters than it was at 6 meters. And then the moment equation was even more complicated at 9 meters, or the moment solution. So I've chosen the same diagram basically, except now this distance from here to here is some arbitrary distance x. But I've still got 31.25 newtons at position A, and then a shear force at V, a shear force of V pointing down at this distance x, and then there's the moment that's acting at x. And when I look at that, I do the sum of the moments, the sum of the forces in the y, and I get the shear force is negative 31.25 newtons. Same as it was before. That hasn't changed much. But then I do the sum of the moments, and the V, the shear force, is not at some specific distance, it's at a distance x, and that's arbitrary. And so when I solve for that, the moment is equal to Vx, goes to the other side of the equation and becomes positive, but V is negative 31.25 newtons, and then times x, right? So just real quickly again, V is equal to minus 31.25 newtons, and the moment is equal to minus 31.25 newtons times x. Okay, and I'll come back to that here in a minute. All right, so there's my solution. All right, then, when I take a look at the other side of B, so I'm at position U now, I have 31.25 still there, I've got 156.25 newtons at B, and then I've got a shear force of V down, again that's the standard, down at U, and then the moment at U. And so some of the forces at the Y, I get V is equal to 125 newtons, right? So that's pointing down, but again, down is positive for the shear. But then the sum of the moments, I have 156.25 times 8 meters. That's the moment due to this force, and that's going to try and rotate it counterclockwise, and so that's positive. But V is trying to rotate it clockwise, so that's negative, so minus Vx plus the moment then at U. And so when I solve this out, 156.25 newtons times 8 meters is 1250 newton meters. It becomes negative because M is staying over here on the left side of the equation. So when I take this over to the right, it becomes negative. Minus Vx becomes positive when I take it to the right-hand side. So I have 125 newtons times x minus 1250 newton meters at that point U. And so one thing that's maybe worth noting here, and your book will get into this in more detail. I'm not going to really detail this too much on videos, but notice that the derivative of the moment with respect to position, right, the derivative of negative 31.25 newtons times x is equal to a constant, right, the slope of this function, which is negative 31.25 newtons. In a similar fashion here, the derivative of the moment over here with respect to x is 125 newtons. Remember, the derivative of a constant is 0. So the derivative of moment is shear, The integral of shear is moment, but there's a constant of integration. It becomes a little bit more complicated, so we're not going to get into that in too much detail here. But we see that in both locations. Also notice these are piecewise functions, right? They are piecewise functions. The moment is negative 3125 for any point left of position B, but it's 125 newtons for any position to the right of position B. And then the moment, that's the shear force, the moment is negative 3125 newtons x to the left of position B, but it's 125 newtons x minus 1250 newton meters to the right of position B. Okay, so those are piecewise functions. And in another video, I'm going to look at how those functions graph, because that'll be kind of interesting. All right, so we're going to take a look at that in the next video. If you have any questions on this, please leave them in the comments below.